Oh, hey folks, Mr. Lee here. All right, so this example is gonna go through one of the congruence proofs, right? So we're trying to use our three-step kind of format here, the CER format, claim, evidence, reasoning, right? So if we have an example like number 1 up here, we're trying to claim that figure ABC is congruent to figure EFG, okay? And the way we're gonna try to prove that or disprove it is by using transformations, okay? So the claim is already written for you. Usually it's gonna be, oh, these two shapes are congruent, or you can say these two shapes are not congruent, and then we'll go through the evidence and reasoning. So the evidence to prove that two shapes are congruent, we're gonna use transformations. So we're gonna start by saying a sequence of the following transformations maps figure ABC onto EFG. All right, so if we can find transformations, rigid transformations that take ABC to land exactly onto EFG, that means they're the same shape and size, which is the definition of congruence, and then that completes our proof, okay? So this one's already started out for you. It says the first step's gonna be a rotation 180 degrees around 0, 0. Okay, sometimes you're not gonna have this given to you. You have to figure out which, maybe 2 or 3, rigid transformations takes one onto the other. But this one's already given to us, so let's perform this first transformation. Okay, so it starts on ABC. So let's remember all of our rotation rules. I want to get the original shape, the pre-image. I'll just go ahead and label it ABC. And then, because we're doing a rotation, you also want your axes, right? You want your axes. You don't need to copy the whole thing. I just like to do that. And then also the origin, okay? Because now we can take our pencil and then swivel it around there, okay? So for 180 degrees, it doesn't matter if you go clockwise or counterclockwise. It's gonna end up in the same position. So let's just go this way. We're gonna go 90 degrees. Once my axes line up again, that's a quarter turn. That's 90, right? So let's go one more. Gets me to here, that's 180. Okay, so let's just pause here. Right, my patty paper shape is right here. And I'm trying to land or map exactly onto EFG, which is right above it. Okay, so after one rigid transformation of 180 degrees, I was able to get here. And hopefully you guys can see that we just need to translate it now up to, and now we're mapped on perfectly, okay? So that's the evidence we're gonna write. We're gonna write translation 2 units up, right? So after that sequence, after a rotation 180 degrees around 0, 0, and a translation 2 units up, I was able to say that the two shapes, or figure ABC mapped onto EFG, okay? And then your reasoning, super simple, right? You're just gonna say rigid transformations preserve shape and size, right? Preserving shape and size, that's your connection of congruence. Go back to your claim. That's exactly what you're trying to prove, right? All of this has to make logical sense. It has to have a logical flow, right? So in the very beginning, you're saying, oh, figure ABC is congruent to figure EFG. So your reasoning better say something about the congruence, right? We used the evidence, the sequence of these rigid transformations. They mapped onto one another, so that's why they preserve shape and size. Okay, rigid transformations preserve shape and size. So there you go.